ready. Oh, there we go. What is that all about?
And please, at this time, we need the Creative Writing Club and MS Student Council to please go to the main gym for pictures now. Please wear your mask over your nose and maintain social distancing.
All right, sorry about that.
Creative Writing Club and Middle School Student Council. Please go to the main gym. Thank you.
Okay, we got to finish section 4.3 and then 4.4. We'll get through both of those kind of today, tomorrow and Friday. Okay, so we finish those review on Monday, and like I said, we need to finish up with tests Tuesday, Wednesday is another 2-day, no calculator part. Okay, for that one, so we'll be good. I'm sure, I don't know if some teachers have mentioned to you, but there is.
Hi, Scott.
Hey.
Can we borrow Madison and Mackenzie for a time off certificate?
Sure.
It'll be quick.
Take it over. They've been pushing out some of the remote schedule stuff if that does happen. So, we'll address that as need be. We can operate pretty normally, but I think the platform we're going to use is Google Meets is typically, it's probably a little bit more user-friendly than the Canvas conference, and it'll be a lot more organized. Not organized is the right word, it wasn't unorganized last time, but you're going to have a lot more responsibilities than before, I guess. Daily classes and daily lectures and all that. So we'll address that as need be. But right now we need to learn about logs. Okay, we'll worry about that remote stuff later. All right, this is not on your guided notes, but just from what do you remember? Log of 5 plus log of 6 equals the log of what? Equals the log of a single number. Anybody know? Anybody remember? Anybody take a guess? 30? 30? I heard 30. That is true. 30. A lot of times your initial guess is not log of 30, but I'm sure some of you said log of 11. Okay, because it says plus. Well, no, you actually multiply. So log of 5 plus log of 6 is log of 30. Log of 20 minus log of 5, that's log of 4. You divide, obviously. And what do we do when we have an exponent? That exponent can come out in front as a multiplier.
Your attention, please, at this time would be Middle School Junior Service Class and Middle School Fellowship of Christian Athletes. Please go to the main gym for your picture. Wear your mask and have your mask over your nose and maintain social distancing. That's Middle
Every
School
time. Okay.
Junior Service Class and Middle School Fellowship of Christian Athletes. Please go to the main gym now. Thank you.
Okay, understand that log 2 to the third power, which is the same as 8. Okay, that's a constant. Okay, log 2 cubed. Well, if I take 3 times the log of 2, okay, same thing. Okay, same thing. Now this property comes up a good bit and is actually very helpful as we kind of move forward with a couple things. All right, the first one, this one again, the product property. Log base A of m times n is equal to the log base A of m plus the log base A of n. Okay, so that is that property. Just kind of quick example of this, if you have the log base 3 of 5x, okay, that's a product. You can write that as the log base 3 of 5 plus the log base 3 of x. You split it apart. You can also start the other direction. You can start with a sum and write as a product. So if I got the log, actually, let me do the natural log. You got the natural log of 8 plus the natural log of 4. That's the natural log of 32. I can multiply those two together. So that's just base E. Okay, it doesn't matter what your base is, as long as they have the same base, we can write that. Now, since this one is not obvious, we're going to prove it, and you're going to want to prove it, I'm sure. You might even want to prove it on the test, just so that you know it. So I'll let you do that. So here is this case here. So prove that log of m times n equals the log of m plus the log of n. And we're just going to do it in base 10. Theoretically, we need to prove it in any base, but we're just going to do it in base 10 and make our life slightly easier. All right, first step. Let x equal log of m and let y equal log of n. There will be 6 steps, and you need to have each one of them down. So that is your first step. Second step. Okay, take each piece and convert it to exponential form. And so what I mean by that is take these two statements, convert to exponential form. Well, so that means I'm going to make this 10 to the x power equals m. And then this means 10 to the y power equals n. So we just converted that. All right, step 3. So now all I'm going to do is I'm going to say m times n equals 10 to the x times 10 to the y. All right, make sure that makes sense. All right, from this statement right above there, if I would multiply m times n, it's got to be true that 10 to the x times 10 to the y has to equal the same thing because of m equaling 10 to the x and n equal 10 to the y. So I multiply those two together, they got to be equal. All right, go back to our exponent rules. 10 to the x times 10 to the y, how can you rewrite that as 10 to a single power? What do you do to the exponents? Add them. You add them. So for step 4, mn is going to equal 10 to the x plus y. All right, now this is probably the key step here. Convert back to log form. Convert back to log form. What's that going to look like? Okay. Luke, what's that look like? Any ideas?
Maybe log base 10 of mn equals x plus y.
You got it. Now you don't need to say base 10. Just say log of mn. Understood to be base 10. So convert to log form. All right, there's one more step. I got to write it down, but why are we done? Why can we be done? What does x equal from the first step?
Log of n.
Log of n. And what does y equal?
Log of n.
Log of n. So if you go back up here, x is log of m. So I can replace the x with log of m. So I get log. Where'd I go? So I get log of mn equals log of m plus log of n. Okay, so you got that. All right, so I wanted to at least prove that one. Okay, but the key thing is you got to start with that first step and convert to exponential form when needed. And the key step is convert back to that log form. All right, so that's why that one works. Now you got the quotient property. Log base a of m over n equals log base a of m minus log base a of n. Okay, for that case there. So we got, and now just a quick case, log base 3 of 7 over x would be the same as log base 3 of 7 minus log base 3 of x. And then if you start with the subtraction, you can write it as a division problem. And then that third one is the power property. So we got the product, quotient, and power property. Log base a of m to the r is equal to r times log base a of m. So you can think of this as natural log of 7 to the x power is the same as x times natural log of 7. The power can go out in front as a multiplier. Okay. Log base 3 of 4 to the 8th power is the same as 8 times log base 3 of 4. Okay, for that. So there's just a couple quick cases of the power property. All right, let's take a look at just some quick evaluations. Given that log base 5 of z equals 3, I'm just telling you that. And log base 5 of y equals 2, I want you to evaluate these two cases here. So the first one is log base 5 of yz. Okay. And it's going to equal a constant. Okay, both of these are going to end up equaling a constant. Well, right now you cannot tell me anything. So use our law of properties. If this is a product, then I can rewrite that as the log base 5 of y plus the log base 5 of z. Once you got it like that, you can do substitution because the log base 5 of y, we already said, is 2 plus the log base 5 of z, which is 3. And now in that case here, we get 2 plus 3, which is 5. So in the end, it just equals 5. All right, take a look at this one here. Log base 5 of 125 y to the 7th. So we want to use those two facts from the beginning there, plus our other properties to come up with just a numerical answer. All right, now we do have a product. It is 125 times y to the 7th. So I'm going to make this log base 5 of 125 plus log base 5 of y to the 7th. Okay, log base 5 of 125 plus log base 5 of y to the 7th. All right, what can I do with that 7? This 7 is a exponent. It can go out in front. Now, it can't go in front of the whole thing, just in front of the log base 5 of y to the 7th. So I got log base 5 of 125 plus 7 times log base 5 of y. If you have, like that first one, log base 5, 125, does that simplify to a constant? Yeah. 5 to what power is 125? That's going to be 3. So you replace that with 3 plus 7 times, what's log base 5 of y? Is that 2 from up above?
Yeah.
2. So 7 times 2 is 14. 3 plus 14, you should end up with 17. All right, so that one simplifies just to the constant 17. All right, so you can be given some scenarios, simplify them to a constant. All right, a couple of key big parts are taking what's called expanded form, writing it in condensed form, and then taking condensed form and expanding it out. There's a lot of little cases on that. So log base 4 of 3 plus log base 4 of 6. Using our properties, that's just log base 4 of 18. Now always examine and say, all right, can I reduce that or can I simplify? Well, 4 to what power equals 18? Is that a nice number? No, so just leave it. Log base 4 of 18, done. You just multiply those two together. All right, second one here. 3, log base A of 4. Well, that's just log base A of 4 to the 3rd power. Do simplify that to log base A of 64. So that's going to simplify. So we want to write that as a single log. All right, now this third one has a few more, I guess, steps to it. All right, the 1/2, that's a constant out in front. Any constant out in front goes in as a exponent. So this becomes log of 36 to the 1/2. So this is kind of the reverse of the power property, okay? Because you can take a power and put it out in front. If you got a constant out in front, you can put it as a power. minus log of 2. Well, that's just 36 to the 1/2 power. That's the square root of 36, which is just 6. So it's log of 6 minus log of 2. All right, what's that going to equal? Log of 3, because you take 6 divided by 2, log of 3. All right, biggest mistake I usually see is right here. Okay. That is log of 6 divided by 2, which is log of 3. The mistake I see is people want to do this. They want to make it the log of 6 over the log of 2, like 2 separate pieces. You can't do that. It's just the log of the 6 divided by the 2. Okay, that would be a separate, or that would be an incorrect answer, a wrong answer. So just be careful there. All right, going the other way. Write in expanded form. Now there's a couple key things. When you are done, you cannot have a product. You cannot be taking the log of a product, a quotient, or a power. So by that is whatever we're taking the log of, you cannot have.
At this time, we need the middle school 7th and 8th grade book club, along with the jazz band. Please report to the main gym to have your picture taken. Please wear your mask over your nose and maintain social distancing. At this time, it is 7th and 8th grade book club and jazz band. Report to the main gym now. Thank you.
Okay, so you can't take the log of products, quotients, or power. So right here, I got a quotient. So make this the log of the numerator minus the log of the denominator. So log base 2 of a squared minus log base 2 of b. Now you've got to take a look at each piece and say, all right, do I need to simplify it further? In this case, you do. You got a power. That power goes out in front. So I got 2 log base 2 of a minus log base 2 of b. And then that's all you can do for that one. Okay. So you are not taking the log right here. You're just taking the log of a. We're just taking the log of b. There's no powers. There's no quotients. There's no products there. All right, for that second one there to the right, there is a couple different ways you can go about this one. This power, so I can make this log 4 times log base 3 of AB. And now this is a product, so I can make this 4 log base 3 of A plus log base 3 of B. All right, now how I have it written is wrong. Okay, how I have it, what would I need to, how would I need to fix that? Because technically that would not be right. Aaron?
Log 3b has to be multiplied by 4 as well.
Right, so when you have this case here, you're thinking, this is basically in parentheses at 4. And so if it splits apart, that 4 is being applied to everything that splits apart. So for this one here to be correct, it needs to be 4 log base 3 of A plus 4 log base 3 of B. Now some of you might have said, well, can I just make this A to the 4th and B to the 4th? That would achieve the same thing. Okay, just depends upon how you go about it. You could have made that A to the 4th, B to the 4th, then split it up. But in the end, you got to have 4 log base 3 of A plus 4 log base 3 of B. All right, copy down that one. Okay, got a quotient. Go ahead and make it the log of the numerator minus the log of the denominator. Log of A times A minus 1. All right, now take a look at each piece. No products, no quotients, no powers. First one has a product, right? So I can make this log of A plus log of A minus 1. Minus, put that 2 out in front. And then you get 2 log of A plus 2. All right, we're taking the log of A. That's fine. No issues there. I'm taking the log of A minus 1. Can that be broken apart? Or can that be rewritten? No, it is fine. It is not a product. There is no quotient. There's no power. You got to leave that. And the same thing here, you get the log of A plus 2. You can take the log of an expression, okay, without splitting that apart. Okay, you don't need to do that. All right, now these properties, and especially the power property, now it gives me the case to evaluate this. Now you guys are spoiled, a lot of you, because you can do this on your calculator, where for, back in the Stone Ages, we couldn't, because I didn't have that little base, and I still don't have it, where it has that little base. Now you can type it in and it'll spit out an answer. Use your calculator. What's that answer? What's to the 3 decimal places? Log base 2 of 7. Okay, Cole, what is it?
Me?
Yeah.
2.807.
2.807. So what that means is 2 to the 2.807. Oops. So 2 to the 2.807. Okay, it's going to be close to 7. We round it off. Now, before that, we couldn't do this. Okay, but now they have it on there. So there is a way to go about this using these properties. So we know that in this case here, 2 to the x equals 7. That's basically what it's saying. 2 to what power equals 7. All right. As long as you do the same thing on each side, your equation will be equivalent to what you started with. So if I could divide both sides by 10, multiply both sides by 4, square root both sides, I'm going to take the log of both sides. Okay? So I'm going to say the log of 2 to the x has to equal the log of 7. Now, the way I have it written is automatically base what? 10. It's automatically base 10. I could make it base 4, make it base 3, but I use base 10 because that's in my calculator. Now, and this is where the importance of logs comes into play, what can I do with this x? It's an exponent. It now becomes a coefficient out in front. So this now becomes x times the log of 2 equals the log of 7. Divide by the log of 2. Divide by the log of 2. And so x is equal to the log of 7 divided by the log of 2. And so if I take log, where's my log? 7 divided by log of 2, okay, I get that same answer. Okay, that's what your calculator's doing. It's taking the log of 7 divided by the log of 2. Now look how this is situated. The 7, okay, is this number here. The 2 is the base. Okay, the log of the number we're taking divided by the log of the base. This is what we call the change of base formula. Now there will be times you need this where you just can't type it into your calculator. Okay, the base, if one of the bases is an exponent, or we want to rewrite something in a certain way. Now this is log base A of m is automatically equal to log of m over log of a. Okay, the log of the number we're using, and then the log of the base. Now this can be any base. So it could be the natural log of m over the natural log of a. It doesn't matter. It's still going to be true. It could be the log base 4 of m over the log base 4 of a. But we usually use natural log or log because it's in our calculator. Okay. But we don't, it doesn't have to be. All right, so compute log base 5 of 13 by using common logs and by using natural log. All right, all you got to do with a common log That's the log of 13 divided by the log of 5. Okay? Log of 13 divided by log of 5. And so I take log 13 divided by log of 5. Okay, and we get that. So that means 5 to that power better equal 13. Okay, 5 to that power equals 13. Now, is log of 13 the same as the natural log of 13? Those are not the same. But if you take the natural log of 13 over the natural log of 5, you better get the same answer. So clear that out. If I take ln of 13 divided by ln of 5, I get the same thing, 1.5. We're going to go to 3 places. What was it, 1.593 or 4? 4. 1.594. Okay, so even though they're different. All right, now either on a separate sheet or you get a little bit of room there at the bottom. We're going to finish the rest of those notes tomorrow. But dealing with some of these things, I wanted to do these 3 in class, and we're going to take about 8-9 minutes, and then I want to make sure we go over them. Make sure sometimes I see some common problems with those. So do these 3. Either right there at the bottom, or you can start your homework by doing those 3. Page 472. All right, Maggie, I'm going to pause this, and there's a high probability I forget to start it. And all right, here we go. There's your 3 answers. Take a look at yours, see if you got them right. And like I said, if not, so you can figure out what you did wrong.
By giving it, it has to be like a single line. Like you cannot use Alex here, like in the spot. So like you combine those 2, you have to write it. So there's oh, is that it right there?
All right.
So there's something like that should be like this.
What is,
Okay.
what about the second 2?
Yes.
So this. Yeah, so that's what we can. For the first one. Yeah. I'm not sure it's right, it's just there, like the.
Yeah, as long as the plus is right, so the right starts.
This one's the, because.
No, that's wrong. Because it's either 4th, cannot be on the bottom.
Okay, so you can see where my 2 the 4th is.
You can't do that. It's gotta be in the top.
Yeah.
Number 39, why would it be plus 1?
Yeah.
Because that would be wrong.
But they're modified.
I know. All right. So these are the common mistakes. Let me explain them. First one, you okay on? All right, 39. What is the original problem there, Ryan? Natural log
Of x plus 1 quantity squared over x minus 3, and then the square root of x plus 4.
square root of x plus 4. Okay, so now you take the natural log of the top minus the natural log of x minus 3 times x plus 4. I'll just make it the 1/2 power. All right, you are subtracting that whole thing. So whatever, if that splits up, you are minusing.
Did you pause it?
I did. Okay. So you're minusing whatever that thing. So you got to treat it like it's in parentheses. So when we split it, the 2 can go out in front of here. But then this becomes like minus the natural log of x minus 3 plus the natural log of x plus 4 to the 1/2 power, okay? And so, well, I should make that a bracket. So yes, it is a plus because it is a product, but since it was in the denominator, we were subtracting that whole thing. So in the end, we're going to have 2 natural log of x plus 1 minus the natural log of x minus 3 minus 1/2. I got to put that 1/2 out in front. Natural log of x plus 4. Okay? So that's why that works. So if you got 2 things in that denominator. Okay, Brian?
So if we had parentheses around it and they were added together, would that be wrong because it's not oversimplified, or?
It's not wrong, but you didn't distribute the negative. So just distribute any constants. I think I say that, but you could not have this as a plus if you did not have the parentheses. Okay. All right, now this one here, 2 things you need to do for 56. The z to the 4th does need to be on the top. And when we are done, I want a single fraction. Don't write these as 2 separate pieces. Single fraction. Because what is the original one for that? Is it 2 natural log of x? Is that right? And then minus.
Yeah, 3 ln y plus 4 ln z.
Okay, so the first thing is, and now you got to understand like the condensed versus the expanded. So we want to take this one and write it like all those other ones there on the other side. So it's just a single log or a single natural log of everything else behind it. Okay, so you can only have 1 ln when we're done. And so when we simplify here, you got to treat this just like order of operations. As you work left to right, what do you got to do first in a normal problem? Okay, I mean, when I say a normal problem, if I had like 10 minus 18 plus 7, you got to do 10 minus 18 first, right? Can't do 18 plus 7. So that means I got to take these 2 and use the quotient property. Well, what did I do first? I got to do something first. I got to make the natural log of x squared minus the natural log of y cubed plus the natural log of z to the 4th. So now on these, I use the quotient property, which means x squared over y cubed plus natural log of z to the 4th. Correct? Big thing here, again, make sure it's just a single natural log. Don't give me the natural log of x squared over the natural log of y cubed. Just the natural log of x squared over y cubed. Well, since this is a plus, we multiply together. I'm going to take 2 steps because I want to make sure you understand how to do that. That's technically correct, but I'm not going to accept it mathematically because I want a single fraction. So make sure you understand where to put that z to the 4th. Since it's x squared times over y cubed times z to the 4th, that would be x squared z to the 4th over y cubed. Final answer. Common mistakes, wanted to highlight them now. Okay, so hopefully you can see those and just be careful of those. All right. Okay, this looks a little bit longer, but these problems aren't long, but there's a lot of different variations, so you do have to hit them. So now I can stop recording.